Thank you. Thank you. Thank you. Oh, I was on mute. What is up, everybody? Hey, hold on. Go Pro Slow, yo. Thank you for the raid. Thank you, everybody who is on joining us today. We are on day 4. What's going on, Thumbstick? What's going on, Zero Day? How y'all doing today? Um, Sorry for the late start. Like I tell people all the time, before everything, I am, a husband, father, and business owner. And of course, a call for, I had a call for business, and then I had to handle some parental stuff. So, thank you for joining. This is day 4. So actually, hold on. Shout out to y'all for coming on here. Joining us today. Thank you for everybody who's rocking and kind of stuck with us. I know we were supposed to start a little earlier, but we are here and we are live. And again, you see, we are in the Wolf Den. We were supposed to be streaming from the Alpha Esports and Technology Center. However, still feeling a little out of it, a little under the weather. Thumbstick, as good as can be, brother. As good as can be. Like I said, uh, parenting is not for the weak. Running a business is not for the weak. Trying to do both at the same time is crazy. So yeah, so let's see. So just to kind of recap what we've been doing, for those of you who are new, my name is Davin. Also go by DJax. I run Alpha Cybersecurity, which is that wolf in the back. But I also run a esports and technology center in the North Georgia area called Alpha Esports and Technology, where we have everything from competitive esports and competitive gaming competitions, teams, tournaments. But then we also teach tech, cyber, security, STEM. The idea is to basically have a center for all things nerd and geek culture, and also introduce young people, or actually people of all ages, because I'm getting a lot of adults too, and introducing them to technology, to STEM, to the gaming industry, the esports ecosystem. Delta Kilo, thank you. I appreciate the love. Appreciate y'all. Seriously. it's been a day. But like I said, so normally we like I said, we go live from the Alpha Esports and Technology Center. But like I said, yesterday we had some issues, had some car troubles, my health. I was a little under the weather. So we just decided to stream live here from the Wolf Den. And now today we are back in the Wolf Den. Because we had some stuff off site, but came back and I was like, I don't know what's going on with me. So I didn't want to expose any of the people who may come by the center to do some gaming or anything like that. So shout out to everybody who is watching us live. We are using Restream. So shout out to Restream. We are streaming live on the Alpha Esports and Technology Twitch channel, as well as the Alpha Esports Technology YouTube channel, the Alpha Esports Technology Facebook channel. And then, of course, we have our Alpha Cybersecurity YouTube, Twitch, and we're also on my personal LinkedIn. So shout out to everybody watching. Shout out to everybody who is on here, just rocking out with me. Let me know how your week is going. Like I said, my week is a week so far, but let me know how your week's going, what you've been working on. If you got any good news to share, let's go ahead and share it. We are we're a community, and any way we can support and uplift and build each other up, let's do that. All right. So but while I do that, I just want to make sure that the LinkedIn stream is going good, because LinkedIn does not play well with Restream. And that means that I can't see if anybody's saying anything on there. But what we're going to do is we're going to go live, and we're going to be streaming Appsec Rabbit Hole. So we are literally starting from the basics. We started off so far with the basics of we started with the basics of the OSI model. We talked about the basics of cybersecurity. Then we jumped into Linux fundamentals. So we did Linux fundamentals part 1. Today we are going to do Linux fundamentals part 2 and 3. And then, like I said, we'll probably come off of Try Hack Me and actually go through how to build our own VM. Delta Kilo, yes, I do. It's very empty and very dry at the moment, outside of like a couple of my esports kids that are on there. But if you want to, I can definitely put that link here in the chat. All right. So with that, let's jump right into it, because like I said, we are a little behind schedule. I wanted to jump on a little earlier. And then, like I said, stuff. All right, so we are here. So like I said, we already did Linux fundamentals. We did the OSI model. We're kind of jumping ahead here. You're kind of getting a preview. You'll see the enumeration and brute force, but we're not doing that just yet, because we got to get to that point. Again, we are starting with the pre-security path. Like I said, I jumped ahead with how to web, and we skipped past how the web works, because what I wanted to do, well, to be honest with you, I made a mistake and jumped ahead instead of doing how the web works. So now we're going to do Linux, and then once we do Linux, we'll create a Linux VM, and then we'll probably do some over the wire stuff. And then we'll jump into Windows fundamentals. We'll take a look at Windows fundamentals 1, 2, and 3, and then we'll circle back to how the web works. And then once we go through that, then we'll go through, the security part of things. So start learning about the basics of penetration testing, web app penetration testing, and then get into the good stuff. But like I said, I want to make sure that everyone who's here and following can get that fundamental understanding. I'm gonna be honest with you. Like I said, it's always a good thing to refresh anyway. So we're going to be going through it together. So if you have any questions, comments, concerns, go ahead and leave it in the chat. If you also want to support, there are so many different ways you can do that. You can honestly, there is buying us a coffee, but honestly, I really don't care for any of that. I'm more concerned with you hitting that like, follow, subscribe button. So this way we can keep it going. Just because again, what everything that we're doing at Alpha Esports and Technology and Alpha Cybersecurity, we plan on, building a lot of content around it, and we want to get that algorithm jumping, especially for our youth programs when they get into running their own streams and stuff like that. So go ahead, if you can, please go ahead and give us a follow wherever you're watching. If you've done so already, I appreciate it. Go ahead and give us a like. So learning Linux part 2. It's a 32-minute video. We aren't watching the videos. Instead, you're stuck with me blabbering about it. But what I'm gonna do is I'm gonna put it in the chat. So if you do want to, if you have a Try Hack Me account, I believe this is one of the free rooms. So if you want to follow along, you can go ahead and click that room, click it and go into the room. And let's go ahead. Alpha ranting about it. So here we're just gonna, again, in the last one we went over some of the basic commands. So we talked about the ls command, the cd command for changing directories, cat for concatenation or reading files, and then we looked at some operators. We also looked at the grep command and the find command. So we're going to be continuing on with our Linux stuff. And it looks like we'll be covering some stuff on SSH. We'll also learn about flags and switches, which basically accompany some of the commands that we use. We'll learn about the file interactions. We'll learn about permissions. We'll learn about some of the common Linux directories. And then when we get into fundamentals part 3, I think we learn more about, let me see what fundamentals part 3 is. We learn more about terminal text editors. So you're going to learn about Nano and Vim. Hopefully we'll be able to exit out of Vim. Just joking. It's a Linux nerd joke. But we'll learn about the processes. We'll learn about a little bit of automation. And then that we'll call that a day from there. So let's go ahead and jump right into accessing your Linux machine using SSH. Now, if you remember yesterday, I talked briefly about SSH towards the end of the stream. You can check that out on our YouTube channels. We talked about SSH basically being a godsend for Linux users. It allows us to remote into our machines. If you've been following this from last week, we kind of talked about VPNs, and we talked about how VPNs allow you to connect to another network via a secure tunnel. SSH is similar to VPNs in the sense that it allows you to remotely connect to a system, and it's secured, it's encrypted, so you don't have to worry about someone being able to basically see what you're putting down in your sessions. But SSH, like I said, is basically a protocol that allows you to access your machine in an encrypted format. With Linux, again, the difference between SSH with Linux and like a VPN or a remote desktop protocol with Windows is that Linux is when you SSH, it's all command line, so it's all command terminal. Remember what I was saying yesterday about Linux? The power of Linux is the fact that it is very lightweight, but learning the terminal is essential. If you're going to work with Linux, you need to know how to navigate through a Linux system via the command prompt or the command terminal. Windows has the graphical user interface. Linux has some operating systems that have a graphical user interface, but the real power of Linux is behind that terminal. So you want to make sure you know those commands. So when we get into our labs and we start doing some hands-on stuff, like I said, we're going to be using the Linux commands versus going in and using the graphical user interface. everything. We're going to open our files in the command. We're going to run our executables in the command. We're going to navigate the file system in the command. We're going to do everything via the command line. Like I said, I will show you how it's done from the GUI, but we're going to stay most of the time we're going to stay behind that terminal. All right. So, have any questions so far? Make sure I didn't lose anybody. Make sure I didn't bore anybody. Make sure y'all aren't sleeping on me or anything like that. We are good to go. Okay. So, SSH, Secure Shell or SSH, is simply a protocol between devices in an encrypted form. Using cryptography, any input we send in human readable format is encrypted for traveling over a network. Where it is then unencrypted once it reaches the remote machine, such as the diagram below. So if you remember my ugly whiteboard session last week, we had the VPN set up where it was, a server and then your PC from home. And we went through the internet, but we drew a tunnel, right? A secure tunnel. Essentially, that's the same thing that's happening with SSH. You're connecting over the internet, but as you can see, when you send a message or you send anything like "Hello World," once it gets through the internet, it gets encrypted, and then when it gets to its destination, it is unencrypted. Okay, SSH allows us to remotely execute commands on another device. Remotely, any data sent between the devices is encrypted when it's sent over the network. So we'll go ahead and start our machine. And then we're also going to, it says we need to start an attack box. So we'll go ahead and start the attack box as well. Because again, we're probably going to go through the process of an SSH session. So right now, like I said, we're just waiting for it to load up. Hopefully it's not as bogged down as it was yesterday, so we can kind of go through the process. But what we're going to do is we're going to use syntax for SSH to connect to our attack box. So we're going to be logging in as a TryHackMe username, and the password is TryHackMe without any quotation marks. We're going to use the IP address of the machine that's displayed in the attack box. So when we come up here, we should get the IP address when it's shown, when it's done. So we'll get that, we'll grab that, and then we're going to run this command, SSH TryHackMe, which is our user, and then it's going to be 10.10.14.123. Is that what it is? Yep, 10.10.14.123. All right, cool. So we're going to run that command. And then it's going to ask us for the password. When it does ask for the password, you're not going to be able to see the password. So you're going to need to make sure that you are typing in the right password. So be very careful when typing it. The other thing you can do is some systems allow you to do copy and paste, where now this way you don't have to worry about it. Okay. But like I said, we're going to go through this fairly quickly. As soon as we get our terminal up and running, you see here. Okay, so just real quick. So this looks like an Ubuntu machine. You see, it does have a graphical user interface. So like if we wanted to, we can click these and start some things. Like if we wanted to look at the full tools folder, we can do that, and we can see everything here in our tools folder. And that's great. Again, that's great that you're able to do that, but you can do the same thing faster and more efficiently using the terminal. Right. So for example, and remember what I was saying yesterday, the difference between a regular user and a root user, you could actually tell that by what icon you see here. So if you see a $, that's a regular user. If you see this hashtag or pound symbol or tic-tac-toe symbol, I'm old enough to remember when it was everything but a hashtag symbol. That is a root user. Okay. But just to show you real quick, remember yesterday we showed PWD to see what directory we're in. So we're in the root directory. So let's say we wanted to access tools, and then I don't know, let's do wireless, right? So if we wanted to do that, we would do this. We would go CD desktop, right? And then from this desktop, we would go to CD tools, and then CD wireless. And then if we type in LS, you'll see, wait a minute, desktop tools, wireless, LS, probably jumping ahead a little bit. Okay, well, you see that we're still in that location. Okay, now I did do that the slow way. If I wanted to, let's just go. Oh, remember what I was saying yesterday as well? If you wanted to go back one directory, you just do CD dot dot. So you see we're in the wireless folder, but when we do that, now we're in the tools folder. Let's do that again. We're in the desktop. Let's do it one more time. We're back at root. Okay. Now, let's say we know the exact location, just like how we just clicked it and it said, okay, boom, you're in desktop tools wireless. We can just do CD desktop tools, and remember you can do tab autocomplete wireless. And as you can see, we were able to navigate right there through the command terminal. All right. So, and then if we just wanted to, if we know we just want to go back to the home directory, which is our root directory, we just type in CD and just hit enter, and we are back. Okay. So what we want to do now is we want to SSH into 10.10.14.123, and we're going to SSH as the user try hack me. So we're going to run the command SSH try hack me. That's our user at 10.10.14.123. And then it's going to say, hey, it's going to give you this message. The authenticity can't be established. Are you sure you want to connect? So basically it's just saying, hey, you know, we're not sure if this is authentic. Are you sure? You're saying, yes, it is. Yes, I'm sure, because this is me trying to access it. So now you hit yes. And now it says we listed this IP address as a list of known hosts. Now it's going to ask for the password. And the password, remember, is the username. So it's try hack me. And as you can see, we are now in here as try hack me at Linux 2. So now we have access to that system. Okay. Cheap viewers on streamboo.com. No, thank you, bot. Okay. Let me just move this up here. All right. So, I mean, we've pretty much handled the SSH situation. We're going to stay here, though, for the next exercise. So remember yesterday we said if we want to see where we are, we would type in this command, pwd, or print working directory. So you can see we are in the home directory and we are in the try hack me user folder. Right. So now if we want to list the contents of what's in the folder, we would type in ls. Okay. So now you see we have looks like a document called important, another document called my file, a document called unknown one, and then we have a folder called my folder. So what if we want to make sure that that's all that's in there? So for example, what if there's a folder that might be hidden, or there's a folder that you wouldn't be able to access regularly, right? So you would then type in ls-a, and that argument stands for all. So this is known as a flag. So anytime you see a dash and then something else around it, that's usually a flag or a switch. So ls-a. Now, if you look, there's a few more folders that weren't that you didn't see normally. So this is the equivalent of when you are in a Windows machine and you select the option to view hidden files, right? So Windows has certain files and folders, but then they also have hidden files and folders because they may not require you to access them on a normal basis. They may have files in there that are sensitive to the operating system that if you tamper with it in any way could could mess up the operating system, can cause the computer to crash, cause you to blue screen to death. So this is something similar, right? So think of that -A flag or -A switch as saying, I want to view all files in Windows. Show me the hidden files as well. So that's how you would be able to see all that. You would run ls-a, and then you'll see it gives you folders that or files that you didn't see before. There's a bash logout file, bash rc, there's a profile, there's a cache. These are all hidden. Okay, and then you had the 4 that we started with. Okay, so these are, like I said, anything with that dot before it, that consider that as a hidden folder or a hidden file. So if you see .bash, so you see that dot, again, that's another way to indicate those files are hidden. Okay, now, so far we showed you what the commands do. We've shown you different commands, and now we talked about switches or whatever. How does anyone know how to access these switches or what these switches are? Well, you can Google them, but a lot of the tools in Linux also allow you to use a help function. So if you do ls-help, it'll give you a bunch of information. As you can see here, here's all the flags that you can use. Okay, so -A is all, capital A is almost all, -- author, that'll tell you the author of each file, -B or -- escape. So they give you, so again, this is your help. So this is like, if you see it and you hit the little question mark or whatever, that allows you to access it. You also should be able to, if we hit clear, if we do ls and we just do -H, oh, it doesn't. Okay, well, sometimes you're able to do -H as well, and it'll be a help as well. Another thing you can do is use what is known as a manual page, and you do that with the man command, right? So manual pages, again, is like a user manual. So they give you a whole bunch of information about the system commands and the applications that are available. Not all, I don't think all tools use it, have a man page, but when they do, it's very useful. So we'll just do man ls. And as you can see, it kind of gives us some of the same information from the help stuff, but it gives us, kind of gives it to us in a little more detail, right? So kind of, you see, it gives us all the different flags, and now it'll give us all that information, the size of the argument. And so it gives you all the directives there as well. It also gives you information on the creator or the author. If you ran into any issues, it gives you copyright information. So again, this is the user manual for this tool. So this is the user manual for the ls function. Okay, and then if you see here, you can press H for help, or you can press Q to quit. We'll just hit H for help, and then you see it kind of gives you it also gives you a summary. So again, this is just a user manual. So we'll just hit Q to quit, and then we'll hit Q again to quit. And now we are back. We closed out our manual. What's going on, Maddox? We closed out our manual, and we are back to our Linux terminal. Okay, so we kind of did all of that. Oh yeah, the other thing was the -H command is stands for human readable. Wait, I'm trying to see where that is though. See, what I noticed is Try Hack Me looks like they may have updated their content, but some of the stuff remain like some of the questions they didn't change. But if you wanted to see what the -H stood for, you would just go here, and then you could just scroll down and see -H equals human readable with a -L or -S. Print sizes like 1K, 234 megs, 2 gigs, etc. Now, pop quiz. What if we wanted to do the man ls thing, but we wanted to just look for that dash h? What do we, if you were here yesterday, what tool would we use if we wanted to look specifically for the dash h and the dash h only? Remember, we used this tool yesterday when we were looking through the log file and we wanted to find one specific line in the log or one specific IP address. What tool, what Linux tool allows you to do that? Nobody? Going once? Going twice? Okay, so remember, it is the grep command. So remember yesterday we talked about grep when we wanted to look for a specific file or a specific information. We would type in the grep command. So if we did man ls, but actually I think we would have to do this first. We do grep here, and then we would go dash h. Did I do that wrong? Usage grep option pattern file. Oh, maybe it won't let us because it's a manual. Okay, so let's see. Grep dash h. I don't think it'll let us do it. ls, or is it an and? Man ls and grep. Can I do that? Okay, well, I take it back. Didn't work. I thought we were able to do it. Whatever. Okay, so I think if this were a regular file and not the man page, we probably would be able to do it. So, nonetheless, the grep command is when you want to look for a specific information. All right, so moving on. Yesterday it says so we covered some of the most fundamental commands when interacting with the file system on Linux. For example, like I said yesterday, we covered the ls command for the listing the directory, the find command if we wanted to find something or look for something, and then we used the cd to change directories. Now we're going to talk about some other commands to interact with the file system. So if we need to create files and folders, if we need to move files and folders, or if we need to delete files and folders. So there's a bunch of different commands. So remember yesterday when we wrote a command with we did cat no, we did echo, and then we typed in please subscribe, and then we did the redirect, and then we called it sub.txt, right? And then when you go in here, you'll see we created a file called sub.txt, and then when you cat sub.txt, there's our please subscribe that we did the echo command to. Just jump ahead a little bit. So what if we just wanted to create a file, but we didn't want to write to it just yet? We just wanted to create the file, right? So this is like when you create a new text document or something like that in Windows. You right click, hit new, and it's like new file or new document, right? In order to do that in Linux, you would do a command called touch. So just like we did the sub.txt, but we kind of echoed, so we wrote something to it and then saved it as that file. If we just want to create the file and have nothing in the file, we would type in touch, and then let's just call this subscribe. And we hit enter, and then we hit ls to list it. You'll see there is a subscribe.txt. And if we were to cat subscribe.txt, you'll see all we do is we get the terminal back because it's blank, because there's nothing in it. All right. Now, let's say we want to make a directory. So we use touch to create a file, but if we want to create a directory, we would type in a command called mkdir. So mkdir, make directory, and then what do we call, what do we want to call it? We'll just call it sub, and then we'll just hit enter. So now we have a folder called sub, and you can see it's blue like the other one, my folder, right? Now, what if we want to move our subscribe.txt file into our subfolder? Well, we would do that with the move command, right? So now we would just type in move subscribe. Now, remember, we did the auto tab complete, and so what happens is, because they both start with sub, it stops, and then if I hit tab again, it's going to say, did you mean this? Are you talking about the subfolder, or did you mean subscribe.txt? So now I just type in one more S, since there is that, and then I can hit the tab for autocomplete. So we're going to move the subscribe.txt into the subfolder. And then we hit enter. If we hit ls, you'll see subscribe.txt is gone. However, if we list the contents of the subfolder, you'll see subscribe.txt is there. Okay. Now, what if we wanted to determine the type of file, right? So okay, no problem, Maddox. Appreciate you tuning in. So now let's say in Windows, let's say you look at lurk. So in Windows, let's say you wanted to check a file, you want to check the properties of a file. You would right click it, go down to properties, and it would give you the information or even the metadata of that file. If we wanted to do that in Linux, we would use the file command, right? So so now if we quickly, remember, we could either do cd sub, and then from there we can use subscribe.txt, but let's back out, clear the screen. Let's say I didn't know what type of file it was. I could do file sub and then subscribe.txt, and then you'll see it tells it, hey, it's empty. It's an empty file, right? There's nothing in that file. Now, let's say we want to echo okay, so we're going to do that. Please subscribe and echo, please subscribe and share. And we want that to go to subscribe.txt. Sorry. Okay. Clear. So now if we go back and run it again, you'll see it gives us information. I appreciate it. I appreciate it. So you can see here now it says the type of file is ASCII text. That's, so it was empty when there was nothing in there, and then we echoed. So we wrote to that file with that redirect operator, and now it tells us that it's ASCII text. So finally, we want to go ahead and remove everything, right? There's two ways you can remove. So first, you can do, if I just wanted to remove the file, I would do rm subscribe.txt, right? and then that would delete the file. But if I wanted to delete the whole folder, we basically are giving it the option, like, so again, let's say you hit delete and it's like, hey, deleting this folder will also delete the contents of everything that's in this folder, all the documents, any pictures, it'll delete all of that. Are you sure? So what we're going to do is here, we're going to say rm-rf sub, and now it deleted everything. So now, as you can see, the sub file, the subfolder is no longer there. The subscribe.txt is no longer there. We successfully deleted everything using that RF flag for the remove command. Okay, so we did all of this. We just named it. We just named it different. Also, they used the -R to remove the entire directory, right? So if you want it, so let's just do this real quick. We'll do make dir sub, and then we'll also do touch sub.txt, right? So if we wanted to do rm sub.txt, great. Now if we do rm sub, it's going to tell us you can't do that because sub is a directory. So we could either do what I did before, which was the rm-rf, or we could do rm-r. Oh, we didn't do, and now we do rm-r, and we successfully got rid of it. If you want to see more information on what the sub command can do, you would do the rm not jelp help, and you see here the different flags. So if you look, the -f was force. So this means, hey, I don't care what the argument is, don't prompt me, force it, delete it, I don't care. -R or capital R or -- recursive would be remove directories and their contents recursively. So basically what we're saying is remove the file, remove the folder, remove everything recursively and force it. Don't tell me about any arguments. Don't prompt me about it. Yeah, I totally understand. I know what I'm doing. Get rid of it. Okay. All right. So we did that. All right, so we did that. We copied the file. Oh, we didn't. Did we copy the file? Sorry. Let's see. We moved the file, but we didn't copy it. So let's just go ahead and do sub.txt again. Echo sub into sub.txt, and now we'll do make directory sub. Okay, so now we moved the file before, but we didn't copy it and move it over, right? So if we wanted to copy it, we would type in the cp command, and then we would say sub, but we don't want to name it, they both sub, so we'll call this sub2. So cp sub.txt, and then we're going to call it sub2.txt. Right? So now you'll see we have two files. And if we cat sub2.txt, you'll see it has the same thing that we typed it, that we echoed in the original one, right? And just in case you want to be sure, and if you keep hearing that drop sound, that's because I'm hitting the tab and it's saying there's a conflict there. But if you see, the contents of both of them are the same. Okay, if you want to file sub.txt, it's going to tell you it's ASCII text, and if you want to file sub2, it's also going to be ASCII text. Okay, if you want to do a word count, sub.txt, it's going to say, going to give you one word and for that. Okay, so we clear all of that. Now what if we copied We copied the folder. I mean, we copied the file. So now, what if we wanted to copy into the folder? We would type in cp sub.txt, and now we would say move it into sub, and we're going to call it sub3.txt. So now what we just did is we said copy this file, but copy it into this folder and call it sub3. So if we do ls sub-sub3.txt, you'll see it's right there. If we hit cat sub-sub3.txt, you'll see it also has the same contents of the other two files. Now, let's just make sure we determined the file type. We did all of that. So we got all the information. So we did everything. So now let's go ahead and get rid of all of this. So we're going to rm sub. It's telling us it's a directory, right? So we're going to say rm -r sub. So we got rid of that because we say get rid of the recursively. We know it's a directory. Okay. We're also going to rm sub.txt, and we're going to rm. And now, because there's nothing else called sub, we can just go ahead and tab complete for sub2. And now we're going to remove that. So you see, everything is gone. Everything is clean like how we had it before. We can clear our terminal, and we are ready for the next exercise. Okay. So now it says it wanted us to do a couple exercises. So if we wanted to create a new file called new note, we would do touch new note. We're not going to do that. Now it says on a deployable machine, it says what type of file is the unknown one. So if we wanted to do that, we would just go file unknown one. You can see it's an ASCII text. If we wanted to move the my file to the directory my folder, we would type in move. We would do move my file into my folder, right? If we wanted to move that file. And then what is the contents of my file? So if we wanted to see the contents of my file, we would type in cat my file, and there is our flag. All right. So again, like I said, I know it's a little intimidating, or it's like learning a new language and stuff, but again, once you get used to it, navigating the Linux terminal is easy. So permissions. So if you wanted to know who could access certain files or certain folders, that's like, again, that's like if you create a folder in Windows as an admin and regular users can't access that file, right? You have to have elevated privileges to access that folder or that file. In Windows, you could check the properties and see who has access, or you can click it and it'll just give you an alert that says you don't have permissions to access this file or this folder. Linux, if we wanted to check to see who had the permissions, we can use the -L command when we are using the ls command, right? So let's just go ahead and type in ls help, and then if we just look for -L, -L stands for use long listing format, and then remember -H was human readable. So we would say use a long listing format and make it human readable. Okay. So when you see a file, let's see if it will. Let's just go here. We'll just do ls-lh. So when you look here, you'll see there are looks like 10 spots, right? So you see -rw, -r, -r, -, right? But then down here you see dr WXR dash XR dash X, right? And so you'll see for different files or different folders, there are different letters in the spots, but with the ones you'll probably see the most are RWX. And what they stand for is read, write, and execute. So R would be read, W would be write, X would be execute. Okay. So that is, I mean, those are pretty much self-explanatory. If you have read access to a file or a folder, it will allow you to read the contents. It will allow you to read the file, right? So there's a file in there, you give it read, you give a user read permissions, they're able to see it. They're not able to make any changes to it. They're not able to edit. They're not able to delete it. They're not able to do anything, right? Or if you give them read access to the folder, they're not able to make any new files. They're not able to, they don't have permissions. Okay. Write will allow them to make edits, write their own files and stuff like that. Execute is you have permission to execute a file, right? Execute a program. So if there's an application or something in there, you're giving that user access to permission to use that program or that app. Okay. So says here, just the great thing about Linux is that permissions can be so granular. Whilst a user technically owns a file, if the permission has been set, then a group of users can also have the same or different set of permissions to the exact same file without the file owner itself. So the reason why you see look like RWX, right? So basically this is RWX, RWX, RWX. Okay. And the reason why is because you can see this is for the user, this is for the user and for the groups. So a user, so for example here, hold on, let me see something real quick. Hold on, let me respond to this real quick, y'all. One second, people. Okay. Oops. All right. Sorry. Had to. Okay. All right. We're good. I think we're good. Sorry about that. Okay. So where was I? Oh, permissions. Okay. So you'll see that there are basically three sets, right? So RWX, 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 right? And then I know you'll see a D here where, and we're going to explain that. That's also probably be self-explanatory. But if you look, these are files. So when you see the first RWX here, that is the file owner, right? So if user 2 created this file that says important, that means since the owner has read and write permissions. Okay. Now from there, this is group, the group owner or the group, excuse me, the group only has read permissions. And then this last batch here is basically everybody else. So this would say for any other user. Okay, so basically what's happening here is that user 2 has read and write access. It's not an executable file, so there's nothing, so you don't have to worry about having the execute permissions, right? User, okay, if there was a group, the group users would only have read access, meaning they can't write to it. And again, it's not an executable, so you don't have to worry about that permission. And then lastly, any other user on the system only has read access. Okay. Same thing here with this file for the my file. Try hack me created the file, so try hack me has read and write permissions, right? But anybody in the group would only have read access. And then lastly, everybody else would also only have read access. So in this situation, if user 2 were to try to access my file, they would be able to read the contents, but they wouldn't be able to change anything. Vice versa. If try hack me tried to access this important file that was created by user 2, they would be able to read it, but they wouldn't be able to make any changes. Now, scrolling down here, you see there is a D here. So the D just stands for directory. So that's just telling you that this isn't a file, this is a directory. But in the contents of this folder or this directory, the try hack me user has read, write, and executable access. The group only has read access. I'm sorry. The group has read access and execute access, but they can't write. And then same thing with everyone else. They can read it and they can execute whatever program is in this folder. So let's just see what is in my folder. No, not my folder. There's nothing in my folder. Okay. Well, if there was something in my folder, they would be able to execute that. Okay. You guys following so far? Any questions? So the file owner has read, write, or read, write, execute permissions. And then the group would have whatever permissions, and then the rest of the users would also have permissions. Okay. So it says using real world context, a system user that runs a web server must have permissions to read and write files on the effective web application. However, companies such as web hosting companies will have to want to allow their customers to upload their own files for their website without being the web server system user, compromising the security of every other customer. Okay. So let's say we needed to switch between users. If we needed to switch between users, as you see here, there is a command called the SU command. So it says SU command takes a couple of switches that may be of relevance to you. For example, executing command once you log in or specifying a specific shell to use. I encourage you read the man page for SU to find out more. However, I'll cover the -L or the -- login switch. By simply providing the -L switch to SU, we start a shell that is much more similar to the actual user logging into the system. We inherit a lot more properties of the new user, including their environment, variables, and the likes. So if you look at the difference, so first let's just do what it said. Man SU. Now I call SU, it says substitute user. Yeah, so that's if you want to, like I said, so you want to change users or anything like that. Like if you needed to quickly access admin or root privileges, you would use that SU command, right? So remember, you're not, just like Windows, you shouldn't be using high privileged access by default. You should have you should practice what is known as the concept of least privilege, which means you should only have enough access to complete whatever your job functions are. So you shouldn't be running around with admin level access or godlike privileges on all of your systems, because by doing that, you'll run into issues. And if that account were to get compromised, then that person who compromised your account would have the same level of access that you have. They would inherit your access. So many times on pen tests, I've accessed a user and they had root privileges. So because of that, it's pretty much done. Same thing on the Windows side. I access a user, or I access an account that has domain admin privileges on Active Directory. It's game over from there, right? I have domain level access. I have domain admin access. I can access any file. I can execute any program. I have access. I'm the admin. I'm the captain now, right? It's over. So what you want to do is you want to make sure you're practicing least privilege. So if that account were to get compromised, they would have whatever access is needed for that job. Now, if you have a situation where, oh crap, I need to access this file real quick, then I would type in the su command, or I would type in, Linux also has what's known as the sudo command, and I would access that elevated privilege for that specific task, and then immediately revert back to my original access. All right. So let's go ahead. We ran them in for SU. Synopsis is SU options. Okay. SU allows users to run commands with a substitute user and group ID. When called without arguments, SU defaults into running an interactive shell as root. For backward compatibility, SU defaults to not change the current directory and only set the environment variables to home and shell. Okay, so basically, if you just do SU just like this, it will. Here, actually, let's do this. I'll show you. So let's cd into my folder first. Okay, so now we're in my folder, and now we want to do SU user 2. Then it's going to ask for a password. What is the user 2 password? Is it also try hack me? Did I jump ahead of that? Boop, 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 boop. Yeah, let's see. SU user 2. Yep. Okay. It was all right. So now, if you look, I went to substitute user 2. Then they asked me for the password. I typed in the password, which was user 2. And now you can see it went from try hack me at Linux 2 to user 2 at Linux 2. But now you see it left us in the directory where we left off, the my folder directory, right? So now if I hit exit, it ends that substitute session and it brings me back to the try hack me at Linux 2. But let's say I wanted to log in as user 2 and start from user 2's home directory. I would type in su-l user 2. Then it's going to ask me for the password. I'm going to type in user 2 for the password. And now, as you can see, I am user 2 and I am in user 2's home directory. And again, the quick cheat is you can tell by your prompt here, right? So when we did it before, we were in the home directory of the try hack me user, and then we were in that my folder. What's going on, Ty? Right? But then when we said no, we logged in as user 2. We essentially think of it as like logging out of the try hack me user and then logging in as the user 2 user. Okay. So now if we type exit, we're back, and we're back as the try hack me user, back in the directory where we left off, the my folder directory. All right. So, we needed to see what was in the important flag. So output the contents of the important flag oh, we need to back up. ls, let's cat important, and you see su user 2, right? Just for shits and giggles, I'll just show you something real quick, right? So who had permissions to the important file? So user 2 had was the creator, so they have read and write access, right? So if we were to cat okay, so you look here. So cat try hack me was here, and we wanted to go into the important file. You'll see it says permission is denied. Why? Because if you look here, every other user in the group, as well as every other user on the system, only have read access to that important file. User 2 is the only one who has write access, right? Now, just to show you, if I wanted to add that, let's log back in as user 2. And now we go ls. There's nothing here. So we are in the home user 2 directory. So we will back up, and then we are in the home directory. So now we'll go cd try hack me, because that's where it is. We'll go into the, no, we don't need to go in the folder. We should be able to hit ls. And there you see we have the important folder. So now if we type in that same thing, cat, hold on, try hack me sucks, and we append that to important, no such file or directory. Nani? Oh, my fault. I didn't mean to do cat. We'll do echo try hack me sucks into important. So now if we cat important, you'll see there's our flag, and then try hack me sucks. And again, vice versa, if we were to try hack me owns the file my file. So if we then put echo try hack me sucks into my file, you'll see permission is denied. Why? Because user 2 only has read level access, right? Only try hack me can write to the my file. Okay. All right. So let's go ahead and let's clear everything out. And now let's go ahead and jump into our common directories. So common directories, again, Linux has their own directory and file situation. So like Windows has, like the System32 folder, or Windows has, the application data or app data is a hidden folder. But like how Windows has their file structure, Linux has their own file structure. So in Linux, there are a couple important ones that you should know, especially when you're pen testing a system and you need to look for specific files or where they're located. So we're going to start first with the Etsy. So the Etsy folder, or the Etsy directory, says is the root directory. And this root directory is one of the most important root directories on your system. The Etsy, or short for etc., is a commonplace location to store system files that are used by your operating system. For example, super users or sudo users or sudo files are highlighted in the screenshot below contains a list of the user's groups that have permission to run sudo or a set of commands as the root user. Also highlighted are the passwd and shadow files. These two files are special for Linux as they show you how your system stores passwords for each user in encrypted format called SHA-512. So if we wanted to do that, we would cd into the Etsy folder or Etsy file directory for etc. And as you see, we hit ls. These are all the system files and folders for the operating system. Okay. So if we wanted to cat the sudoers, right, we cat that. It says permission is denied. Why? Because we don't have access to that. So if we, let's say if we said ls-lh sudoers, you'll see only, so the root user created it and you only have, so the root user has read access. Wait, yep. And then anybody in the group has read access, and everybody else, which the user 2 falls under, has no access whatsoever. Okay, so that's why I can't read that file. Okay, now let's say we talked about the passwd and the shadow file. So when working on a pen test, if you gain access to a Linux system, you are going to want to access the password file and the shadow file, and you have to get both of them, right? You can't just get one, and I'll explain why in a second. But as you see here, same thing with the passwd file. The root user can read and write to it. Anybody in the group can read it, and then every other user can read it. How about shadow? Only root can read and write. Everybody in root's group can read. Nobody else has access. And that's done by design. So let's clear real quick. So if we wanted to cat the password file, it's like, sure. Here's what you can see. Not much. Kind of gives you your user information, what your home directory is, binary, and bash, right? Doesn't give you much to work with. So this is why you would need to have access to the password and the shadow file, because the shadow file is where is basically your encrypted password. And then when you need to crack those two, when you need to crack it, you need both of those files together. Okay. So again, they show you how your system stores passwords for each user, right? So you would need to have access to both of those. Okay. So the next folder is the variable folder. So let's clear. No, sorry. Let's clear, and we'll go back to home directory, and we'll clear again, and let's go back. Actually, let's get out of the user 2 and go back to our try hack me user. Okay, cool. All right, so clear. So now we have our variable directory. This is any of the variable data. So this is one of the main folders, or one of the main root folders on a Linux install. This one stores any data that's frequently accessed or written by services and applications on the system. For example, any log files or from running services and applications are going to be written to the variable directory /log file, or other data that is not necessarily associated with a specific user. So if we cd into the var folder, cd into the var folder, ls. So you'll see here is our backups folder, any cache, any crash logs, libraries, local, any log files, any another log file folder, any mail. So print spools, temporary files, www. That's for like any web information, like our web server information. So all of that would be stored in the /var file. Okay. All right. We're going to kind of speed up now because we still got to get through Linux 3. All right. So the root folder is the actual root, is the root folder, right? So the root folder is the root location for the system user. Okay, so that's like the right. So you have your home folder, right? So again, we do pwd. You see, this is home. Try hack me. But if let's say if we did cd root, cd/root, permission denied, right? We can't access that because we are not the root system. We are not the root system user. We are not domain admin. We don't have permissions to access that. Okay, it says there isn't anything more to this folder than just understanding that it's the home directory for the root user. But it's worth mentioning as a logical presumption that the user would have their data in a directory such as home root by default. Okay, so this is both. So if you're looking at like a hierarchy, the root folder is actually not here. Okay, so this is our home folder. So let's see if we did. So now we're in the home folder and now we're here, right? So now you see we have our bin, dev, home, lib32, media, optional or opt, and then our root. Okay. So where we were was in the home. So if you just do cd home real quick, and then you see try hack me Ubuntu and user 2. That is the home directory, and that's where these users are. But if you see, root isn't here because root is here. Okay. So this is where the root user lives, while the rest of us live in the home directory, rest of the users. Now, the temp folder, TMP, says this is a unique root directory found on a Linux install. Is short for temporary. The temp directory is volatile and used to store data. Now, if you remember, if you know anything about memory, volatile memory basically means it's temporary. You're able to access it while you're on, but it's something that only needs to be accessed for that interim or that one time or whatever. The moment you shut down or reboot the system, all the contents in that folder is cleared out. So as a pen tester, that temp folder is perfect for us because of the volatility. As a pen tester, when you gain access to a Linux system, you're going to go ahead. If you need to add any tools or anything like that, you're going to want to try to add it to that temp folder. Why? Because it's volatile. So if we need to hurry up and install a program, we're installing it in that temp directory. Do what we got to do, and then we're going to force that machine to shut down. Or if we can't force it to shut down, we're going to seize it up to the point where the user, the unsuspecting user on the other end, is going to shut it down or reboot it for us. Because the moment that is shut down or is rebooted, all of that stuff is cleared. So we don't have to worry about it. Okay. So that's why the temp folder is important for pen testers. All right. So now with that, we can go ahead and get up out of here. Let's terminate that. Summaries, again, this is talking about how to connect to it. So just to summarize, we SSH into the machine. We used some of the commands that we learned yesterday, and we used flags and switches, and we also learned how to learn about them by using the help flag or the man page. We learned about the file permissions and switching users and how to read file and folder permission information. And then we talked about the important root directories. Now, as you can see, there's a whole bunch of other directories that we didn't cover. You can go ahead and read that on your own time. All right. So now we're going to jump into Linux Fundamentals 3. So we'll go ahead and share that. Let's go ahead and deploy whatever machines we need to deploy. Looks like we're already deployed, but we'll just go ahead and start and make sure that we are good. Okay, yeah, so our previous machine was terminated, so now we need to do Linux 3. Okay, so what we're going to cover while we're waiting, as you can see, we need to start our attack box as well. So what we're going to do here is we're going to learn about text editors. Text editors, we talked about, like I said, we talked about the echo command. We talked about the operators like the redirect and then the append. But what if you actually have to, access a whole text document, or you need to write more than just a quick echo command or whatever? You would use a text operator. So that's similar to using something like Microsoft Word or Notepad or WordPad in Windows. So you have two. There's Nano and there's Vim. Each of them have their own unique characteristics, but at the end of the day, they're the same thing. They're used for text editors, right? So if you need to type up something, type in your notes. If you need to create a quick bash script or something, more than likely you are going to do it in one of these two text editors. I am one of the psychopaths who actually like to use Vim or VI. Nano, you can use either or. It just all depends on what you want to do. Okay, so again, while we're waiting, Nano, all you have to do is create a file using Nano. Just type in the Nano to say where we want to run that program, and then create the file name. Okay, once we press and execute Nano, it'll launch. It'll get into a text thing, basically a text document, and you can use up and down or the arrows to start a new line, and then hit enter on your keyboard. Okay. Nano has a few features that are easy to remember and covers most general things out of the text editor. If you want to search for text, if you want to copy and paste, if you want to jump to a line number or find out what number line you are on, you can use these features of Nano by pressing the control key, which is represented as up, like this little up tick on Linux, and a corresponding letter. For example, if to exit, we would hit Control X to exit Nano. Okay, Vim is a little more advanced. Yeah, Vim is a little more advanced. It allows you to, it's a little more customizable. You can highlight syntax. Vim works on all terminals where Nano might not be installed. Again, that's probably why I prefer Vim or VI, because like I said, if I need to quickly create a script or run something, most of the time Vim comes by default on most systems. Nano is not on all Linux systems. Okay. And then there's a bunch of cheat sheets and tutorials. Okay, so let's just go ahead and run through it real quick. So we're going to do Nano, and we're going to call it please sub. And then as you can see, it opens up Nano, and the file is called please sub. So now we would just go ahead and type this, blah, 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 blah. And then when we want to exit, we would hit Control X. It's going to ask you, do you want to save? You're going to type in Y for yes. And then it's like, hey, what's the file name you want to write to? And we called it please sub. So we'll just go ahead and hit enter. And now if we cat please sub, you'll see it has all of that we just typed. All right. Now, if we wanted to do Vim, same thing. We would just type in Vim, no caps. So we would type in Vim. We'll just call this one sub now. And now there's a couple things you would have to do here. So, for example, if I wanted to write to it, I would type I to insert, right? And then I would hit escape. And then when I was done, I would hit Control C to quit. And then if you look, it'll say, hey, type in QA exclamation point if you want to exit. So then I would just type in QA. Wait, hold on. So I would have to now go in here. Right? So I'm sorry, I have to do colon QA. Okay, so we typed in what we needed to type in. So now if I wanted to do that, I'm saying, hey, shift, thank you, colon QA exclamation point. And now if I wanted to do sub underscore I quit. I'm sorry. I quit out of it. I don't think I did that properly. No, I didn't. I meant I had to do right and quit. My fault. So again, I was reading this over here. So again, let's see. We'll just do Vim sub now. Okay. Now we type I to insert text, and we would just type blah 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 blah. All right. Now what we did before was we quit and we said don't make any changes. Now if we say, and now if we hit escape because we're done inserting information, and then we do colon WQ and we hit enter. Now if you look, we have sub now, and now if we cat sub now, there's our file that we created. Okay, so we're just going to go ahead and hit rm-rf for recursive enforce, and I want to get rid of sub now, and I also want to get rid of please sub, and we did that successfully. We got rid of everything. So that is it for our folder there. Now, if we it says just to edit task 3 in Nano, what is the flag? So we need to find, oh, we're the root user right now. We were supposed to SSH. So let's go ahead and SSH first. We jumped a little bit ahead. So we needed SSH into try hack me at 10.10.156.149. It's going to say the authenticity. We're going to go ahead and hit yes. It's going to ask us for the password. The password is try hack me, and give us a second. We are now logged in as try hack me. We type in ls. There is task 3. If we type in nano task 3 to edit, you'll see it says THM text editors. And then when we need to get out of here, we'll just hit Control X. Since we didn't make any changes to it, it didn't ask us if we were writing anything, but you see, let's just run it again. Right, THM text editors. Now we're going to go ahead and do, just as a extra credit, we're going to type in via Vim task 3. Takes a little second to load, but as you can see, we have it here as well. And now if we need to get out of here, we're going to type in WQ to quit. colon Q to quit. And And if you look, the last time we did Q, it had to do QA exclamation point or whatever. That's because we're saying quit and we accept the fact that we're not accepting any of the changes. So now we're just doing Q because we didn't make any changes. We're just quitting out of it. All right. So that is it for text editors. Now, if we needed to download a file, there's a couple ways we can do it. One is the wget. If we actually needed to try to pull something from a Windows or a PowerShell, there's another thing for that, but I'm pretty sure we'll get to that later. But if you need to transfer files from from a server to yourself, you would use the wget command, right? So in a pen test, remember what I was saying before about the temp folder? Well, when you're on a pen test, or even when you're doing a CTF, you would basically fire up your own web server, which I'm pretty sure we're going to do in a second. But you would fire up your web server, and that web server would have all of your files or scripts or anything that you would need to run. Okay. And then what you would do is, if once you gain access into that Linux machine or that Linux target, you would navigate to the temp folder, and then you would run the wget command to download whatever scripts or whatever programs you have sitting on your server and move it over to that temp folder. And remember, we're moving it to that temp folder because it's the temporary location. So we would allow us to download what we need to do, run what we need to run, and then when we're done, we can reboot the machine or crash it or whatever, forcing it to shut down and basically covering our tracks. The other thing you could do is secure copy. So secure copy uses the same concept as SSH. It's going to allow you to copy files from a location securely, and it's going to be encrypted. So it's going to encrypt it when you initiate it, and it's going to decrypt it when it gets to the destination. And you can basically use secure copy from your system to a remote system, or vice versa, from a remote system to your system. Okay. Provided that we know the usernames and passwords for a user on your current system and a user on a remote system, blah, blah, blah. Okay, so that's if we wanted to do that here. Okay, so what we're going to do is first, oh, there it is right there. We are going to fire up a web server. Now, also, remember what I said before about the folder location? What if you needed to blah blah blah, if you needed to upload anything to your web server, you would go into cd var www, right? Learn how to type, Davin, and then you have your HTML. So basically, whatever you would need to put in in your web server, you would put it in this location. Okay, let's just go into the HTML. Right, and now you have your cats and dogs JPEG, right? So any file or whatever I needed to put in there. So let's just go ahead and do. Let's just create touch. Let's just say with the same concept. Touch sub. Oh, touch cannot. Permission denied. Really? You can't create a file in here? Okay, whatever. So we can't access it with this user. But like I said, you would create whatever you needed to do in that folder, and then when you would and then when you fire it up, you would wget from it. So anyway, let's go ahead and start our Python server. So we're going to do Python 3 -m, and then we're going to do HTTP, not HTTP, HTTP.server. And then what it's going to do is create a server on port 8000. And now what we want to do from there let's open up. Wait, try hack me. Hold on. Now let's use wget blah 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 blah. Do I have both things open? Bad save room options. 1010. No, there we go. Ten 190.2. Okay, cool. All right, we're good. Now let's go here. All right, so we're going to cover the use of wget. This command. Oh, I'm sorry. So we need to go. Try hack me at my machine. Okay. All right, so we need to go to, and that's the IP address, right? 10.10.156.149. Yep, 10.10.156.149. Great. All right, so what we're going to do is we're going to type in wget http 10.10.156.149, and then oh, that's right. It was called what? Cats and dogs, right? I think that's the name of the folder. That was the name of the file. Oops. 8,000. So on port 8,000. 404 file not found. All right, let's do what you just said here. File, right? Because you said file. Error 404 file not found. Okay, so let's just do this real quick. Now, as you can see, excuse me. So as you can see, our server is picking up the information that we're getting from 10.10.190.2. All right, so it says flag.txt. So let's just do that one. 404 file not found. Oh, because it's a hidden file. My bad. Boom. So now if you look over here, all of these you see here was a get 404. Cats and dogs 404. But all the way down here, flag 404. But it was a hidden folder, so we said get dot flag, because remember that dot means it's hidden, and then that was a 200 for successful. So if we now look in here from this system, you won't be able to see it. Why? Because it is a dot, which means it is a hidden folder. So what we would have to do is do ls-a for all. And if you look here, we have our dot flag.txt. So now we would have to do cat dot flag.txt to get the information. And you see it says wget web server. Now, just because I'm curious as to what went wrong, I want to cd var www html cats and dogs jpg ls-a cats and dogs. Oh, okay. So maybe I'm in the wrong. Oh, that's right. I'm in the wrong one. It should I should be in www and not HTML. So That's my fault. Okay. That's why. Okay. And then if we wanted to do SCP, can we do SCP? We should be able to do SCP. Yeah, let's try SCP. Right. So let's go back here. We are in our home. Task 3. So let's see if we can do SCP. Try hack me at what was it? What was it again? 10.10. 10.10.156.149 usage. What did I do wrong? What did I forget? Oh, duh. Task 3. I forgot the name of the file. Cannot, no such file or directory. What? Ubuntu. Oh, at task, home, try hack me. Task 3. Okay, now try hack me's password. Try hack me. What? Okay, so maybe we can't do it. It's going to keep making a liar out of me. Okay. It's going to keep making a liar out of me. Okay, whatever. Fine. You don't want to work. It's okay. You don't have to. All right. All right. So now let's just go ahead and move on. So where are we now? Let's start. Let's close out the root folder, the root one. Let's clear out here, and then we'll just type in PS. So let's move into processes. Y'all still with me? Just double checking my LinkedIn stream, making sure we're good. Okay, all right. So just making sure, y'all, we still here, we still good. Awesome. Looks like we got a few more users on YouTube and Facebook. Shout out to everybody who's listening, who's tuning in. Ty, I'm all right. Glad to see. So yeah. So processes. So processes basically are programs that are running on your machines, right? So think of this like you're opening up Task Manager on Windows, and you want to see what programs are running, what processes are running. You would do that in Linux with the PS command. Okay, so they're managed by the kernel, where each process has its own ID that's associated with it. That process ID is also known as a PID or a PID. The PID increments for the order in which the process starts. So the 60th process would have a PID of 60. Okay. So we can use the PS command to provide a list of any processes that's running in our user session, as well as some other information such as status codes in the session that's running and how much usage time of the CPU it's using. The name of the actual program command is being executed. So when we over here, it says, so this is process ID 204, and it's giving you that information. Whereas over here we have for our bash, we have process ID 1121 and 1381, and that is for bash and PS. Okay. Note the screenshot above. The second process has a PID of 204, and then in the command below, it is incremented to 205. To see the processes run by other users, you would that don't run from a session, we would do the aux command. So it would be ps aux. Okay. So here again, let's just follow what they're saying. So if we run ps again, you'll see it's been incremented. The PS went from 1381 to 1384. We'll type it again: 1384 to 1385, 1385, 1386, 1387, 1388, 1389, 1390, so on and so forth. So let's go ahead and clear. So now let's type in ps aux, and now you'll see all the processes that are running from everything. So you have your root. So this is your root user, and here are all the commands. So, or all the processes. Okay, so these are all running from root. So then that's the system, syslog, daemon, TryHack Plus. So these are all the processes that are running from the different users. Okay. And then if we just do that over here, you can see we only have our little two processes here, which you see here, 1121 for TryHack Plus. Same thing right here, 1121 for TryHack Plus. Okay. So now it says you can see in this one, you can see 5, or notice how, or note how we have root or cmnatic. Another useful command is the top command. Top gives you real-time statistics about the processes running on your system instead of a one-time view. These statistics will refresh every 10 seconds, but will also refresh when you use the arrow key to browse various rows. So we'll just go ahead and clear. And now we'll just type in top. And now you'll see the same thing. Okay, so it's refreshing, and it's giving us a little bit more detail information. So you see the memory. Like I said, it's giving us a little bit more details. Now, if we wanted to kill a process, this is like going into Task Manager and saying, I don't want this program to run anymore, close it out, right? You can run the command called kill. And it says below are some signals that we can send a process when it is killed. So there's sig term, which is kill the process, will allow it to do some cleanup. Sig kill is killing the process that doesn't do any cleanup after the fact, or sig stop, which will stop or suspend the process. Okay, and then it talks about how processes start. Let's start off by talking about namespaces. The operating system uses namespaces to ultimately split up the resources available on a computer, such as CPU, RAM, and priority processes. Think of it as splitting your computer into slices, similar to a cake. Processes within the slice will have access to a certain amount of computing power. However, it will be a small portion of what is actually available to every process overall. Namespaces are a great way are great for security as it is a way of isolating processes from another. So remember when we were talking about subnetting, think of this like subnetting, but for processes. Okay, or creating a VLAN and having that set up where they're two separate networks and they can't communicate with each other. It's the same thing with the namespaces. You can create a namespace here and a namespace here, and they're isolated, And the only things that could see the namespaces are the things that are, or the processes that are running in each of the namespaces. They'll be able to see each other, but they won't be able to see the other namespace. Okay. For example, once a system boots and it initializes, system D is one of the first processes that are started. Any program or piece of software that we want to start will start as what is known as a child process of system D. This means that it is controlled by system D, but will run as its own process, although sharing the same resources from system D to make it easier for us to identify the like. Okay. If we wanted to run a program at boot, right? So that's like if you go into Task Manager and you say, hey, I want this to start every time, right? Like I want my VPN to start every time I run. I would go in there and say, enable boot up, start at boot up. You can do that with the system control command in Linux. Okay, so this will allow you to interact with the systemd process and basically say, whenever this is running, what's going on 0 day, I appreciate it. So whenever I boot up, I want this process to run. Okay. For example, if you want Apache to run, you would just type in system control start Apache 2. Okay. If we wanted to stop it, you would just replace the start with stop. Okay. So we can do 4 options to when you're doing system control: start, stop, enable, and disable. So again, start would start the process, stop would stop the process. Enabling it to run at startup, you would do system control enable, and then vice versa, system control disable. Okay, let's see. Here we're running echo high THM, where we expect the output to be returned to us like this at start, but after adding the AND operator. Now remember, yesterday we said the AND operator allows you to run things in the background so you don't see it. You're just given the ID of the echo process rather than the actual output as it's running. So if you put you did echo, high THM, then you said a high THM, and it says, okay, the process ID for that is 16889. And then you try to run it again, and it fell under that process. Okay. We can do the same exact, like executing things like scripts rather than relying on the operator. We can use Control-Z on our keyboard to background the process. It's also a very effective way of pausing the execution of a script or command, like the example below. We'll get to using Control-Z and pausing things when we get into exploitation and things like that. Now that we have a process running in the background, we can run our script background sh. Okay. All right. And then if we wanted to bring it to the foreground, we could use FG. So we would pause it with Control-Z and then the AND operator, and then we could use FG to bring it to the foreground to focus like below. Bring it, and then we can see the FG command is being used to bring the background process into the use on terminal, where the output of the script is now returned to us. I just want to see something real quick. Fix it. You should join infosecstreams.com. You know what? I've heard of that. I've heard of InfoSec Streams, but I don't know enough about it. I don't know who's on there. You know, the funny thing is, someone made something like this a while ago. And I was on it. I'm not on this one. Um, you know what? Yeah, sure. Yeah, you could definitely add me to it because, like I said, I was on it before. I don't think it was. Like I said, I'm not sure if it was this one, but there was a process. I'm just trying to look. Cyber insecurity, profits. Yeah, when I was doing when I was the height of like InfoSec Unplugged, I was on, like I said, I don't think I was on this one. No, I was because Chad B Noob. Yep. So yeah. So this must have got redone and I was taken off of it because I'm inactive. Yep, because there's all has red, blacks of cybersecurity. Hold on, let me see. Let me see if I can find myself. Breaking in, Chad B, Noob, Dark Star, DEF CON. Yep, DJax 120. Yep. So I'm right. I was here. Okay. That was a long time ago. Right. And then if you open the link in a new tab, it should bring you to Alpha Cybersecurity. Yep. Yes. Yeah. Yep. I had to add. Yeah. You had to add your information to the GitHub. So like I said, I changed up my Twitch handle. But yeah, it's DJax1 now. Because I was going back and forth. Like I said, the last 2 years have been interesting. Didn't know if I was gonna get back into doing cybersecurity like full time. And yeah, so that's kind of how that happened. Um, where are we? Oh, let me go back to sharing my screen. Yeah, so it's DJax1 now, MSEC. But yes, I was there. I was once there. I mean, y'all know the cybersecurity content game can get weird sometimes. And it was yeah, 2023 and 2024 was just some weird times for me. 2025 seems to be a little bit better, but it has its own weirdness about it. Um, I'll rant about that another day. All right, so we did all of that. What command would start the same service as the boot up system control? Okay, foreground. All right, so automation. Um, so now we're going to get into cron jobs and cron tabs if we need to automate certain processes. So users may want to schedule a certain action or task to take place after the system has booted, right? So for example, I have on my Windows machines, I have a bat on my at the gaming center, I have a batch script that runs every time it boots up. And the batch script basically cleans out the temp folder. It checks, it basically goes through a kind of a quick cleanup process once everything is booted up, right? In Linux, you would have something like a cron job that you could tell it to run something similar, or you could tell it to run at boot. So users may want to schedule a certain action. Hey, no problem. Fix it. Thanks for tuning in. Again, shout out to GoPro Slowyo for the raid earlier. Like I said, it started late, so we're grinding through it here. But yeah, appreciate it. Like I said, we're going through this. We're gonna jump into some AppSec stuff. Like I said, but I'm starting literally from the bottom and working the way back up. But I appreciate it. Get some rest. Make sure you get your 7 to 8 hours of sleep. Okay. So now, so launching your programs. So for example, like let's say you wanted to back up files, or you want to launch something like Google Chrome or Spotify as soon as the system booted up. You can do that by running a cron process, and then you interact with the cron jobs with the cron tab. So cron tab is one of the processes that started during boot and is responsible for facilitating and managing those cron jobs. Okay, so cron tabs are basically a special file with formatting that's recognized by the cron process to execute each line. Um, when you do some CTFs and stuff like that, sometimes you can basically pop a shell by using it. You don't really see that too much in the real world, but like I said, I've seen some CTFs where it's like, oh, you change the cron jobs, and it allows you to run that process. Okay, let's use the example of backing up files. You may wish to back up CMNatix documents every 12 hours. We would use the following formatting. So you see here 0, so that's /12 that's to represent the 12 hours. You're copying everything recursively into the document, and you're moving it into the variable folder, and then the subdirectory for backups. Interesting feature of cron tabs is that these also support the wildcard or asterisk. So that's what you see here. If we do not wish to provide a value for that field, I appreciate it. If we do not wish to provide a value for the field, we don't care what the month, day, or year executed, only that it's executed every 12 hours. So again, minutes, hours, days, months, years. Okay, that's how the cron jobs are formatted. Seconds, minutes, hours, days, months, years, from left to right. Whew, okay. Interesting. Okay, so this can be confusing to begin with, which is why there's some great resources. Cron tab generator that allows you to use a friendly application to generate your formatting for you, as well as the site Cron Guru. Cron tabs can be edited using the cron tab-e, which is a flag for editing, where you can select an editor such as Nano to edit your cron tabs. Okay. Again, you see it here. They ran everything and they put it to dev null. Okay, so to ensure you're connected and deployed to the instance running cron tabs. So let's go ahead and do that. Permission is denied. Facilitate. Not cron tab and cron tab. Oof, I am. All right. Oh, that's why, because I didn't do cron tab -e. So you see here, if I wanted to edit a cron tab, I could just do cron tab -e. And then it says the cron tab is reboot to the variable op processes.sh. Okay. And when will the cron tab deployed on instance 10.10.156.149? So let's get up out of here. 10.10.156.149. .10.10.156.149. Oh yeah, no, at reboot. Okay. Making sure. Okay. So system packages and repos. We're almost at the end. Because then we have logs. And like I said, there isn't too much that we could do there. All right. So packages and software repos. When developers wish to submit software to the community, they will submit it to an apt repository. If approved, their programs and tools will be released into the wild. Two of the most redeeming features of Linux shine to light here. User accessibility and the merit to open source tools. Using the ls command on Ubuntu 2004, these files serve as the gateway registry. Okay, so if we were to go to cd and then we go cd etc apt, and then we hit ls. You'll see we have the configuration files, the preferences files, sources list, and then trusted. Okay. While operating system vendors will maintain their own repositories, you can also add community repositories to your list. This allows you to extend the capabilities of your operating system. Additional repositories can be added using the add app repository command or by listing another provider. For example, some vendors will have a repository that is closer to their geographical location. Normally, we'll use the app command to install software into our Ubuntu system. The app command, now we're not going to do that in here because this isn't our machine, but basically if you needed to update, upgrade, add any tools, you would use this app command and then whatever flag. The app command is a part of a package management software also named app. App contains a whole suite of tools that allow us to manage the packages and sources of our software and to install or remove software at the same time. One method of adding repositories is to use the add app repository command we illustrated above, but we're going to walk through that process and of adding and removing a repository manually. While you can install the software through the use of the package like the package, the benefits of app means that whenever we update our system, the repository that contains pieces of the software that we add will also get checked for updates as well. Okay, and then they kind of go through an example of adding Sublime Text to the Ubuntu machine. The keys are essentially a safety check. So here's our software. So to start, we need to add the GPG key to the developers for Sublime Text 3. Note, TryHackMe instances do not have internet access, so we are not expecting you to add this machine that you deploy, as it would fail. So you would download the GPG key and use the app key to trust it. So you would wget q-0 https download Sublime Text and then enter this information here. Now that we've added the key to the trusted list, now we can add Sublime Text repository. So now you would just go ahead, touch Sublime Text list, ls, add that, and then you can, okay, so then you would now use a nano or a text editor to save Sublime Text 3 repository to the created file. After we added this entry, we need to update app to recognize the new entry. So you do that by doing app the apt update command. And then once it's successfully updated, you can then install it by running apt install Sublime Text. And then if you need to remove any packages, you can go add app repository -- remove, and then you would type in the process name. Okay, by manually deleting the file we previously added, once removed, we can just use app remove software name to app remove, and which is app remove Sublime Text. All right. Lastly, logs. Logs, again, depending on whether you love them or hate them. I mean, logs are everything. But for our SOC folks, our DFIR folks, logs are everything. For offensive folks, you might not like logs so much. You might have to try to find ways to bypass or delete logs, because logs do exactly what's in the name. They log the activity. They log what you're doing. They log your actions. So we talked about logs earlier in Linux fundamentals, but just to recap, it's located in the variable folder or the variable log directory. The files and folders containing log information for applications and services that are running on your system. The operating system has become pretty good at automatically managing these logs in a process known as rotating. I've highlighted some logs for 3 services running on an Ubuntu machine: an Apache web server, logs for the fail to ban service, which is used to monitor attempted brute forces, for example, and then UFW, which is used as the firewall. So these are some important logs here. So again, your Apache, so that's like your web server, any information that goes on your, any web stuff. So remember when we fired up the web server and we kept getting the 404 messages because we were trying to transfer the data back and forth, all of that was being logged. Okay, the failed to ban log, that's going to monitor any failed login attempts. So like you're trying to guess a password or anything like that. Anytime it fails, anytime you get a try, anytime it says wrong password, it's going into there. And then lastly, you have your firewall log. So if you create any firewall rules in your Linux system, any actions that happen and affect the firewall is going to get logged in those files. Okay, these services and logs are a great way of monitoring the health of your system and protecting it. Not only that, but the logs for the services such as a web server contain information about every single request, allowing developers or administrators to diagnose performance issues or investigate an intruder's activity. So remember what I was saying? Everything that we were doing on that web server, it was getting logged. Two areas of interest are your access log and your error logs. Okay, so obviously those are kind of self-explanatory. So your access logs are what accessed what, who accessed what time, where, what's the information. Error logs are any type of errors that happen in any type of transactions. Okay, so there's also logs that store information about how the operating system is running itself and the actions that are performed by users, such as authentication attempts. Okay, so now it says look for Apache 2 logs on the deployable Linux machine. So we are here. Let's see. So if we need to go into, we need to back out here. So we're going to cd var logs, and then we are going to hit ls, and we want to look at the Apache folder. So we are going to cd into Apache 2, hit ls again, and then you see we have the access log. So now let's just clear the screen because I'm pretty sure there's going to be a lot. Permission is denied. Oh, are we in the wrong system? I think we're in the wrong system. Yes, we're in the wrong system because we're still in that SSH system. We're still in the SSH connection. All right, so we need to cd var log Apache 2, and then we're going to cat access.log, and now you'll see here we have one log here for 10 193 68 89 10. Let's just maximize the screen. What is the IP address of who visited the site? As you can see, it's different. And that is because, yeah, all of that is different. That is, yep, all that's different. Anyway, okay, so again, it looks like things were updated. So that's why we're not able to get that proper answer. But with that, we are this is the end of the Linux fundamentals. Like I said, I know we kind of rushed through a lot of it, but like I said, it's pretty self-explanatory. It kind of goes, like I said, we covered all the introduction. We covered what was needed to be covered from some of the basic commands, how to look for the commands, how to look for the instructions for said commands. Like all of those things come with with Linux. So it's one of those things where it's kind of like you kind of have to be in it. So again, this is why we're going to go through the process of creating our own Linux machine and kind of go through that process. And then we're going to use then we're going to go to this handy dandy page here. So what we're going to do is we're going to maybe not until later on this week. Like I don't think tomorrow I have Fortnite practice. So remember, I am a esports coach and I have my Fortnite practice tomorrow. But basically, this is just for basic. Is a game for beginners. You kind of go through the process of how to access different things in Linux. So, for example, you're going to need to know how to SSH. So, we're going to learn how to SSH in level 0. And then from level 0 to level 1 is going to say now we need to SSH, and we need to find a file, or the next level is stored in a file called README located in the home directory. So now we're going to need to learn how to change directories, how to do the ls command, how to cat, how to file. Du is one that we haven't covered yet. But then if you click here, du estimates file and space usage, and then and basically this is the man page for it. Okay, so when we go through Bandit again, it's basically running us through how to navigate Linux, right? So now that's if we so now we need to get the password to access the next level. And then once we do that, it adds on. So every level builds on the last level. So we're going to start with SSH. Then from SSH, we're going to learn how to do ls, cd, cat, file, do, and find. And then from there, we're also going to need to do again ls, cd, cat, file, do, find. It's going to, and then it says the password for the next level is stored in a file called dash location in the home directory. So now we're going to have to learn. So we're going to have to probably, that hints that we're probably going to have to do a little bit of extra digging. So this is where we're probably going to have to learn how to use some of our flags. And then in level 3, same thing. We're going to have to look for a file called spaces. Level 4, you're going to have to go, you have to do more, right? So like I said, as you go in here, you have to find, you're going to have to learn more and more commands. So and as you can see, there are 34 levels. So obviously we're not going to get through all the levels in one sitting unless we do like, a longer stream. Like how long have we been streaming today? We're almost at 3 hours. Well, honestly, it's more like 2 hours because like I said, we were dealing with some stuff. But basically it builds on every single, and because every single time you're going to have to do more, you're going to have to do it, but it builds on each of them. Like you're going to have to SSH into every one of these machines. And that's how we're going to learn. Basically, that's how you learn Linux, right? There's also, I wonder if that VM is still there. See, I'm old school. Let's see. These are old, but that's okay. So that's damn vulnerable Linux. I'm looking for, that's Pwn OS. I can't. Okay, that's Keoptrix. I'm trying to find. There was a box that was like solely focused on Linux stuff in VulnHub. But basically what I'm alluding to is, since we're going to build a virtual machine for our lab, we might as well go ahead and find, start building a small lab. This is basically how I learned pen testing, was going through this process of building out labs. And the beauty of the labs is, like I said, it's its own environment. So you don't have to worry about, as what I'm doing legal? Am I allowed to access it? Because you're doing it in your own environment. like I said, I'm trying to find. Like I said, there's a Linux box, and honestly, I probably still have it in my folder of stuff. But anyway, I'm gonna go ahead. So like I said, we're done here. So let's go back. Share this tab. So we finished up everything. So the next thing we're gonna do is we're going to come off of Try Hack Me for a little bit, which, oh no, it's gonna break our streak. Whatever will we do? But we're gonna come off of that, and instead we're gonna build a virtual machine. So we'll probably do both. We'll do a VMware box as well as a we'll do VMware as well as Oracle VirtualBox, just so you can kind of see the differences. Again, I'm a little weird where I actually like VirtualBox over VMware, but because when I'm building labs for jobs or things like that, I'll use VMware for that. So like I said, so we'll go through that process, and then we'll start off. We're going to build an Ubuntu machine, and then we're going to build a Kali Linux machine, and we're going to do over the wire with the Ubuntu machine. And then when we start getting into like some of the pen testing stuff, we'll do with Kali Linux. And the reason why I like to do both is because when we start getting into the Appsec stuff, you'll probably notice I'm going to phase out the Kali box for the Ubuntu machine, just because I can customize it how I want to customize it. So again, I want to give a special shout out to GoPro Slowyo for the raid. I want to shout all of y'all out for I want to give y'all a shout out for rocking with me and staying with me through the process. This is probably the largest stream I have had in a while. So shout out to y'all. All right. So shout out to y'all for rocking with me. Shout out to Fix It 42 for recommending that I get added back to the InfoSec streams. Thank you for 0 Day for their raid of people as well. So all right, so thank you to them as well. MSec, appreciate you. To my other folks here, I appreciate you. Ty, Thumbstick. I know Thumbstick's probably over here somewhere. We have Maddox. We have everybody. So again, appreciate y'all so much for rocking with me, being patient with me. Like I said, we're going on 3 hours. Probably, like I said, part of it was my fault because again, I had y'all basically sitting there on hold. So thank y'all. Again, just thanks for rocking with me, honestly. I hope to be back I'll be back at the center tomorrow, but like I said, I have esports practice. I might jump on stream after. I think practice is done around 6. So I might do a quick stream on it, but it's gonna be if I do get on stream tomorrow, it's going to be Minecraft. We are going to do a Minecraft stream, and we are going to start over with the Minecraft stream, and we're gonna get that going tomorrow. All right. So again, thank y'all for tuning in. Like I said, if y'all haven't done so already, please go ahead and subscribe to the channel wherever you're watching. If you are watching on Twitch, please go ahead and subscribe to the Twitch channel. It's djax_1, and it is also Alpha Esports Tech, because again, I'm streaming on 2 pages. If you are on LinkedIn, go ahead and send me a request on LinkedIn. If you are watching me on YouTube, go ahead and follow me on YouTube. That's Alpha Cybersecurity or Alpha Esports and Technology on YouTube. I'm also streaming on the Alpha Esports and Technology Facebook page. Go ahead and follow me there. And yeah, that is it for me. So I'm gonna go ahead and get up out of here. I appreciate you all, and I will see you guys briefly tomorrow. All right. So peace out, be safe, and take care of each other. All right. Peace.